Good morning all of you. We will discuss today timer and counter. So when you go for the timer and counter, so in today's session we will discuss about introduction of the timer and counter, different examples of timer and counter, go for special function registers of timers and counters, examples on TMOD register, and we will conclude this session with the help of summary. So when you go for the timer and counter, these two are used for generating time delays, measuring pulse durations or timing intervals, counting pulses or events, and generating an interrupts. So when we can say as a timer and when we can say as a counter. So timer is a register which is used to program to count internal clock pulses, and counter is a register which is programmed to count external pulses. So in 8051 microcontroller we have two timers, timer 0 and timer 1. They can be used either as a timers to generate a time delay or as a counter to count events happening outside the microcontroller. Both timer 0 and timer 1 are of 16 bits. They are accessed as two separate registers, lower byte and higher byte. If you consider example of timer 0, we can consider lower byte of TL0 and higher byte as TL0. And for timer 1, lower byte as TL1 and higher byte as TH1. When used as a timer, the register is programmed to count internal clock pulse, and when used as a counter, the controller is programmed to count external pulses. The timer mode can be used for pulse width measurement. So for timer programming, we have to consider three types of SFRs, that is special function registers, as timer register, timer 0 and timer 1, TMOD register, that is timer mode register, and TCON register, that is timer control register. So consider example of timer register. In this case, we have to consider timer 0 and timer 1. These two registers are used to store the starting values of timer 0 and timer 1. Each timer is of 16 bit. So for this two register, we split this in 2 bytes, lower byte as TL and higher byte as TH. So if you go for the SFR values for this timer 0 and timer 1, the TL0 we have the value as 8A, TH0 is the higher byte of timer 0, the value is 8C, the lower byte of timer 1 the value is 8B, and the higher byte of timer the value is 8D. So both the timers we can use, and to load your count value in these timers we can take the help of TL0, TH0 or TL1 and TH1 as per the requirement of the timer. The second SFR is timer mode register. Both timer 0 and timer 1 can be used the same register called TMOD to set the various timer mode operations. It is a 8-bit register and which we can call as bit addressable. The meaning of bit addressable here is that we can set or reset any particular bit of this timer register. If you observe this, we have two timers, timer 1 and timer 0. The lower 4 bits D4 to D7 as for timer 0 and higher bits D0 to D3 are for timer 1. If you observe gate, C/T bar, M1 and M0, these 4 fields are same to timer 1 and for timer 0 also. Consider MSB of this format as gate. This bit is used to start timer or counter operation by hardware. So when this bit is 1, it enables timer or counters only when interrupt pin is high and timer run is set to logic 1. When this bit is 0, I am considering about gate pin. So when this bit is 0, timer or counter operation is controlled by software. So we have to do the timer programming. So always we have to consider this gate pin is equal to 0. Now let us go for a second bit, C/T bar of timer 1 and C/T bar of timer 0. C/T bar indicates counter oblique timer. So timer is active low. So if you consider this bit in TMOD register, which is used to decide whether the timer is used as a delay generator or an event counter. Timer operation, this bit is 0, which is input from system clock, and counter operation, this bit is 1, which is input from TX input pin of the controller. Now let us consider M1 and M0 of this TMOD register. These two bits indicates the timer is operating in which mode. We have 4 types of operating modes now, and these 2 bits are with us. For 00, it is mode 0, it is 13-bit timer/counter mode. For 01, it is mode 1, 16-bit timer counter mode. For 10, it is mode 2, which is 8-bit auto reload mode. And for 11, it is mode 3, rest split timer mode. Mode 0 is of 8-bit value with 5-bit prescaler. Timer value range from 0000H to 1FFFH. For mode 1, timer value ranges from 0000H to 4 times FH. 8-bit auto reload, we have to consider 8-bit values which can be loaded in TH, which is holds a value that is to be reloaded into TL for each time it is rolled over. And mode 3, split timer mode. Now let us consider an example for timer. Indicate which mode and which timer are selected for each of the following. Move tmod, #01H, move tmod, #20H, and move tmod, #12H. Now here hash indicates the immediate value. So all these 3 cases comes under category of the immediate addressing mode. Now let us see about the first case as move tmod, #01H. If you represent this value of 01H in binary, and if you put this value in TMOD register format, we can write as 0, 0, 0, 0, 0, 0, 0, 1. So in this case, for timer 1, all values are 0, and for timer 0, your all values of gate C/T bar and M1 is 0, but M0 here is 1. So when M1 is 0 and M0 is 1, it indicates mode 1. So for this example, timer 0 in mode 1 is selected. So if you consider the second example for tmod, #20H, if you represent this 20H in binary format, we'll get the value 0010 0000. Now if you observe, all values of timer 0 are 0, means timer 0 is not selected. But if you observe the value for timer 1, gate is 0, C/T bar is 0, M1 is 1 and M0 is 0. As M1 is 1 and M0 is 0, it indicates we are using mode 2. So for this example, timer 1 in mode 2 is selected. Now consider one more example as move tmod, #12H. So for this value, we can write as 0001 for 1 and 0010 for 2. So this indicates the binary value for 1 to H. So if you observe here for timer 1, mode 1 is selected, and for timer 0, mode 2 is selected. So here both the timers are selected, but timer 1 is selected in mode 1 and timer 0 is selected in mode 2. We can select both the timers at one time. So this is the advantage of the TMOD register format, which we can operate as which timer we can select and which mode we can select. Either we can select timer 0, either we can select timer 1, or we can select both the timers at one time. And apart from 4 different type of modes, we can select any one of the mode at one time. So consider example 2. We have to write the instructions to do the followings. Case number A, set timer 0 in mode 1. Consider 8051 crystal frequency to start and stop timer. Now crystal frequency here you have to assume as a standard frequency as 12 MHz. Set the value F0ABH to timer 0. This is the value of counter to load this value into timer register. Which timer you are using? Here they have mentioned timer 0. Now start timer 0. So for these three cases we have to write the different instructions. Now as we have seen how to select timer in which mode, so for that case we have to take the help of this Tmod register format. Now we have to go for timer 0 in mode 1. So if you go for the solution of the first case, move tmod #01. So to select timer 0 in mode 1, so timer 0 bit we have to select in mode 1. So M1 should be 0 and M0 should be 1, and remaining values for the timer 1 it should be 0. So your value is 01H to select timer 0 in mode 1. So the instruction for this case A is move tmod #01H. For case B, the counting value F0ABH we have to load into timer 0. Because in case A we have selected timer 0. So here you have to select timer 0 now. If you consider timer 0, we have considered TL0 and TH0 as two different register values of timer 0. So we know the TL0, the SFR is 8A. For TH0, the SFR is 8C. So we are using these two registers of timer 0. So higher byte of F0, it will load into the value of TH0, and the lower byte of ABH, it will load into the TL0. So the value of TL0 and TH0 we can write by instruction move TL0, #0ABH. So this value is of lower byte which can load into the lower byte of timer 0, and F0H value we can load into the higher byte of timer 0. Now the last case, it is mentioned as we have to go for start timer 0. So to start this timer 0, we have the timer control bit, and in that timer control bit we can use the TR0 bit of timer. So TR0 bit is used as a timer set bit or timer reset bit. With the help of this we can start or restart of your timer. So set B TR0, it indicates that we can set the timer 0 bit. So timer 0 can be started with the help of this particular instruction as set B TR0. So by these three instructions we can select timer 0 in mode 1. We are loading the value of F0ABH as a counting value to timer 0, and to start the timer 0 we can write as set B TR0. So with this I have concluded with my summary part. As already we have discussed, the timers are used to generate a time delay. It can be used to measuring pulse duration or timing intervals. It can be used for counting pulses or events, and it can be used for generating different type of interrupts. As we know that timers are used to count internal clock pulses, and counters are used to count external pulses. The counters are used to count events happening outside the controller. In this session we have seen different SFRs, TH0, TL0, TH1, TL1 and Tmod register. So we have seen for TL0 the SFR is 8A, for TL1 SFR is 8B, for TH0 SFR is 8C, and for TH1 SFR is 8D. So Tmod register SFR, the value is 88H. So different examples we have seen and how we can evaluate different timers in different modes that we can see with the help of this Tmod register. So in this session we have seen how to select timer and different modes of timers using Tmod register. Thank you.